Hello, Math 130 students. We are going to pick up on page 7, section 2.2, slope of a line and rate of change. So this section is all about the slope. The slope is a ratio of change in y to the change in x. So the slope is rise over run, and if we have two ordered pairs, you can think of it as y2 minus y1 over x2 minus x1. And we want to make sure that the 0 is not in the denominator because that would give us an undefined, right? If you were to plug this into your calculator, 5 divided by 0, on your calculator it's going to say error because this is undefined. It is not possible to have a fraction with 0 in the denominator. That's when something bad happens. So here, the first example, it says find the slope of the line passing through these points. So I'm going to go ahead and label these. I'm going to say this is x1 and y1, and this is x2 and y2. So now I'm going to plug it into this formula. So m is going to be equal to, I know that I have subtraction in between, so my y2 value is 8 and my y1 value is 1. My x2 value is 6 and my x1 value is a negative 4. So when I plug this into my calculator, 8 minus 5 over 6 minus my negative 4, I'm going to get a positive 3/10. So here, my slope is going to be a positive, let me write that a little bit nicer, 3 over 10. So that is going to be my final answer for part A. For part B, we do the exact same thing. So I'm going to call this my x1, y1, my x2 and y2, and again I'm referring to this equation up here. So I'm like, okay, m is going to equal to, and I know I have subtraction, numerator and denominator, my y2 is negative 4, my y1 is negative 8, my x2 is a negative 5, and my x1 is a positive 1. So now my fraction, when I have a negative 4 minus a negative 8, it's really addition. And at the bottom, negative 5 minus 1, that's going to give me a m is equal to a negative 2/3. So my fraction is going to be m is equal to a negative 2/3. Now, for the next example, it wants us to graph a line passing through the point and given the slope. So whenever we want to graph, we are going to start at the point. So that is going to be the first thing that we do. So we're going to start at the point negative 1, positive 4. So there's my point. Now my slope, what this is telling me to do is to go up 1 and to the right 4. Or I can go down 1 to the left 4. Since this is talking about my rise over my run. So if I went up 1 and to the right 4, I would be here. If I started at the y-intercept, or sorry, the point that it's given me, and if I go down 1 and over 4, notice how I still end up on more or less the same line. So that is how you're going to graph. So now for part B, I'm going to start at this point, so negative 6, negative 2, that's here. So this slope tells me I'm going to go down 2 and to the right 3 since it's negative. So down 2 and to the right 3 is here. I also could have gone up 2 and to the left 3, and I still would have ended up on the same line. So that's how I'm going to be graphing, with a point and a given slope. Now for this example, it says graph a line whose equation is given using its slope and y-intercept. So here, maybe the nicest thing to do is isolate the y. So you can see the y is equal to mx plus b, where m is the slope and b is that y-intercept. So my goal is to isolate the y variable. So if I have 3x plus 2y is equal to a negative 2, I'm going to subtract 3x from both sides. So that 2y is equal to a negative 3x minus 2. Now I'm going to divide each side by 2. So that y is equal to a 3/2 x minus 1. So this tells me that the y-intercept is going to be 0, negative 1, and my slope is a positive 3/2. Oh, and look at this. I almost did something because I was going too fast. It was a negative 3x. So that also should have been negative. It's important to go slow when you're doing these problems because one negative sign is really going to change everything. So this is really saying that I can go down 3 and to the right 2. It also means I can go up 3 and to the left 2 if I chose. But I still have to start at that y-intercept. So my y-intercept's at 0, negative 1. So if I go down 3 and to the right 2, I'm here. If I had decided from that red dot, right, the y-intercept go up 3 and to the left 2, I'm still on the same line. So I connect the dots and that's what my line is going to look like. And I'm going to do the exact same thing for part B, right? I still want to get the y isolate, so goal. Get it into the y is equal to mx plus b form. So I have 8x over 5 minus 2y is equal to a negative 8. So I'm going to subtract 8x over 5. So on this side, it can cancel. So I'm left with a negative 2y. And now I have negative 8x over 5 minus 8. So then from here, it's the same thing as multiplying by a 1 over negative 2. So 1 over negative 2 and a 1 over negative 2. So now I'm going to have y. I'm going to have a negative 8x over 5 times my 1 over negative 2 minus 8. And I have my 1 over negative 2. So now I can see that a negative times a negative is going to become a positive, and 2 can go into 8, so 2 divided by 2 is 1, 8 divided by 2 is 4. So now I have this 4/5, and I still have x. And now I have a negative times a negative, so that's going to give me a positive, and if I think about it, 2 can go into 8 4 times, so plus 4. So now I know that my y-intercept would be a 0, 4. So on my graph, I have my first point at 0, 4. My slope is equal to a 4/5. That means to go up 4 and to the right 5. It also means I could have gone down 4 and to the left 5. So if I had decided to go up 4 and over 5, I would have been here. If I had decided to go down 4 and over 5, I would have been here. So you would still be on the same line. Okay? It just depends on what you want to be on the left-hand side or the right-hand side. And that is the end of section 2.2. So that was a very short, sweet, and to the point. If it was confusing at all, which math can be at times, please reach out, send me an email, contact the Math Success Center or the tutor. Thank you.